Today we are walking through Latent Agents, a post-training procedure for internalized multi-agent debate.
What is the central problem this paper is trying to solve?
The paper starts from a practical bottleneck. Multi-agent debate can make language models reason more reliably because several model instances critique and revise one another. But the standard version is expensive at inference time. You run multiple agents, ask them to talk over several rounds, and only then produce one answer.
So the old setup improves the answer, but spends a lot of tokens getting there?
Exactly. The authors want the benefit of debate without making the model speak out the whole debate every time. Their answer is called IMAD, short for Internalized Multi-Agent Debate. The idea is to train one model so that the debate process becomes part of its internal computation.
Can you show the full training flow before we get into the results, sir?
This diagram is the main method flow. First, the authors collect debate traces from several agents solving arithmetic problems. Second, they use supervised fine-tuning so a single model learns the visible structure of that debate. Initial answers, revisions, and consensus. Third, reinforcement learning pushes the model to keep the correct answer while shortening the generated reasoning.
Where does the debate stop being a visible transcript and start becoming internal?
The transition happens in the reinforcement learning stage. After supervised fine-tuning, the model can imitate a full debate trace. Then the reward schedule gradually lowers the allowed length from about 2,000 tokens to 500 tokens, while the reward for following the explicit debate format decays. The model is still rewarded for the correct answer, but it is no longer encouraged to expose every debate step.
What reward are they using to make that pressure precise?
The reward combines two pieces. The format term checks whether the output still follows the expected debate structure when that matters. The clipped correctness term rewards a correct answer only within the current length budget. That is why the reward can first teach structure, then slowly stop paying for long visible debate.
Does the paper give an example of what the training traces look like?
Yes, this example shows why the trace is useful, but also why it is costly. The agents start with different arithmetic solutions. Some are wrong, some are right, and the later revision round lets them compare the work and converge. IMAD uses traces like this as training material, but the finished model should not need to print all of it during deployment.
Once the debate is internalized, how do they check whether separate agent perspectives still exist?
They use activation steering. The authors train debate date, where three agents have distinct reasoning styles: chain of thought, self-critique, and program of thought. Then they compare hidden activations for completions from one agent style against completions from the other styles. The average difference becomes a steering vector for that agent perspective.
What does the steering vector equation define?
This equation defines the vector for agent style I. The dataset contains prompts and completions. The term H at layer L is the model activation for a prompt and completion. The equation subtracts activations for non-matching agent styles from activations for the target style, then averages that contrast over the dataset. That gives a direction the authors can add or subtract to make the model behave more or less like that agent.
What evidence shows that those directions actually track the target agent style?
This result compares a base model with the internalized model using our OUGEL against target agent outputs. The internalized model stays above the base model across the steering range, and the area under the curve rises from 0.80 to 0.903. The chart reports a 12.7% gain, which means the extracted direction preserves target agent behavior more consistently after IMAD training.
So higher steering does not just make random text. It stays closer to the intended agent style.
Right. That matters because the paper is not only claiming better accuracy, it is claiming the internalized model has separable internal directions for different agent roles. If those directions were modeled, steering would not reliably move the model toward the chosen style.
The method diagram also mentions suppressing malicious agents. What exactly did they test there?
They trained an internalized model on debates that include malicious traits, then extracted steering vectors from that model. The comparison is against a base model where steering vectors are extracted from contrastive system prompts. The key question is whether negative steering can suppress bad behavior while preserving normal task performance.
What does the result chart say for evil and hallucination traits?
The solid lines show trait expression, and the dashed lines show GSMAK accuracy. Under negative steering, both models reduce the harmful traits. The difference is that IMAD keeps accuracy much steadier across the steering range. The base model fluctuates more and can collapse at extreme coefficients, especially for hallucination.
And the dotted perplexity lines are about whether the output still looks coherent.
Yes, perplexity is used as a rough coherence signal. The paper reports an asymmetry. Positive steering makes the base model's perplexity spike, while IMAD can move toward more on distribution generations. Under negative steering, IMAD maintains or improves coherence while suppressing the trait, which is the useful safety direction.
What about the main efficiency result from internalizing debate?
Across multiple models and benchmarks, the paper reports that internalized models match or exceed explicit multi-agent debate, while using up to 93% fewer tokens. That is the headline trade-off: keep the debate benefit, but remove most of the visible debate cost.
What is the safest takeaway for someone applying this idea?
The safest takeaway is that IMAD is not just a compression trick. It is a post-training procedure that turns a multi-agent conversation into a single model behavior that exposes internal directions that can be measured and steered. The evidence is strongest for the tested arithmetic debates, persona-style agent subspaces, and malicious trait steering setup.
So the result is promising, but still tied to the tasks and steering settings they evaluated.
That is the right level of caution. The paper gives evidence that internalized debate can reduce token cost and make agent-like behaviors more controllable. It does not prove that every debate skill or every safety behavior will transfer automatically. The contribution is a concrete training recipe plus measurements showing where the internal structure becomes useful. That wraps up this paper walkthrough.